Class, the next topic is the relation between electric field and electric potential. So let us see relation between electric field and electric potential. See, any si marker like relation to talk say electric field si karina denote it is denoted by E, and electric potential karina denote it is denoted by V. So you are going to derive the relation between electric field E and electric potential V. Then just like what we have done repeatedly, let us take charge Q here at the point O, then at the distance, at certain distance, let us bring in the charge from certain distance. Let us say from A to B, the charge, particular test charge Q naught is displaced. From A to B through a displacement. Let us say how much dx has it, or let us say dr. Dx or dr, it doesn't matter. Some money dr to distance, dx to distance. Dr vector displacement of the test charge Q naught from left to right, from E to B. This is dr vector. Then just imagine the electric field direction. The Q naught is placed at which point? Q naught is placed at the point A. Then how much? In which direction will be the electric field due to this Q? This will be directed along this direction, E vector. So although the electric field is directed towards the right side, displacement is in opposite direction. Then how much should be the angle between E and dr? This should be opposite angles. Opposite angles, how much is the measure of angle between them? They should be 180 degree. Let us try to find the small work done. Let us try to understand each and every term. What you are going to find? You are going to find a relation between electric field E and potential V. Then what is E? Electric field at the point A. Due to charge Q. What is dr vector? Dr vector is the displacement of the test charge Q naught from A to B. In opposite direction the displaced electric field certain displacement A to B displaced small work done dw as you know, work done is the dot product of force and displacement dr vector. But force ti kariga manai, electrostatic force ti kariga manai koina aina kari hydride. This is equal to test charge into electric field. Yai ko adu beta agadi masidagi koina EF sigi mota kari ibe yare Q naught E vector later Q naught E vector dot dr vector. Because as you know, this F electrostatic force is equal to charge Q naught times the electric field intensity. Then dot product expand over see dot product expand over ganda kaitani Q naught sima dum laser E says minus Q naught se dw ni Q naught se makha the som the transpose dw by Q naught. This is equal to E vector dot dr lemau ni. There see Q naught se makha thang E dot dr dot product expand or see E dr AB cos theta natra cos 180 degree. Cos 180 the value kaya no ay nahamok so high cos 180 is minus ni aduna sige cos 180 si mo ta kai na mo sin ba yare there should be a minus sign here. So this is the work done. This is brought out from the concept of work done, dot product of force into displacement. So then let us come back to the definition of potential difference now. Okay, by definition of potential difference or electric potential, this dV amount of potential difference, this is small work done dW per unit test charge Q naught. This comes from the definition of electric potential or potential difference. V is equal to W by Q naught. So if the potential is very small, work done will be very small. That's why dW luga dV ka sijinai. So if you find, see, let us place it like this. dW by Q naught says minus puthodi. See kai tare dV tare. We are just interchanging the sides, left side and right side. Yai ko. Adu di yamo. See equation ani se munayo. Left side dW by Q naught, right side to so na kangi left side to so dW by Q naught. If the left side are the same, right side ani sige term matik ani siga manakam thokra. If in two equations side to left side ani pulap mana ta right side mana bai masana ta. So comparing the above two relations, what you are going to have is minus EDR is equal to dV tare. Adu eba tare gadi kai dore asigi sidagi nang ithok tare gadi kai tani sidagi nang E putho adi E equal to minus se songkan thangdokrani dV by dr ko E equal to minus dV by dr. So this gives you the relation between electric field E and electric potential V. And now see E equal to minus dV by dr se. Now karam interpret tawani haibang matamda si dr ni ko ngang sa. Karam interpret tawani haibang kanda electric field is equal to the negative gradient of electric potential. Negative gradient. D by minus D by dr say masi by koina gradient ko ne aba. Kare ko. Aduna E is equal to electric field is equal to the negative gradient of electric potential. So this is the relation between electric field and electric potential. Now let us try to apply this particular expression into certain physical conditions. Physical conditions in the master minor apply to when have to yes. Karigumba reason amada mafam amada laiba electric potential se constant or electric field se karamai oini and hangbaya. In that case, now question se kya ko karamai hai. If the electric potential in a region is constant, what happens to the value of electric field in hangbaya? Alita aragati ke dorani sida D say V is constant or a na. If V is equal to a constant, or then your electric field E is equal to minus d by dr of V. As you know, differentiation of constant is 0 tavnina, therefore your electric field E should be equal to 0. Electric field should be 0. V constant always the electric field will be 0. This is the first condition to be on which this relation can be applied. Then anishu badana mo karigumba si ona taina bada toina electric field se region amada 0 oiba taragadi what will happen to the value of V and hangbaya. V se 0 tagadra taroidra 0 tagadra taroidra and hangbaya. Just the reverse of the previous one. If E is 0 oi havenina, E is 0 oi havenina, Kadorani, condition check is on to any, Karihani Hamukanda. If E is equal to 0, then Kailani aside E to Kaigamana minus dv by dr gamane E0 by d minus dv by dr to kya minus then minus dv by dr, this is equal to 0. And aside the substitution differentiation of some quantity to 0 data, the quantity must have to constant or another. That's why this v should be either 0 or it should be a constant. This implies v is a constant. Electric field 0 ay mapam do maduda always v is 0 oi ni hai ngai lete madu yong kai ni v do either 0 oi basu ai differentiation of 0 so 0 ina v do 0 oi basu ai na hanaga kari oi basu ai constant oi basu ai and differentiation ki calculation ai gona concept is v do kai variable some variable that depend on r the pyramid ko differentiate or kan e puto basu ai. There are several other applications. So I hope you can understand the relation between electric field and electric